And I'm going to pick up on the point about technology. Our people need technology. Is the technology in autonomous today or tomorrow? I think one of the panelists did say that. So I'm going to welcome the next panel lead. It's a group of experts now that we'll see coming on, talking about the next generation, the next step for GSE, autonomous, next generation and next step for GSE. We're going to look at some of the experiences from the panelists in implementing and using autonomous GSE throughout our airport systems. But I'm going to welcome the team leader for this panel, Mr. Sunny Bhatt, the Manager of Ground Operations, Innovation and Efficiency at IATA. Sunny, I'm going to ask you to come and lead and introduce the group. Welcome.
Hello and welcome everyone to our session about autonomous GSE.
I was telling him I was in LA.
I would like to start with introducing our speakers. So first, if I may invite Cyril Lebu, who is the TrackTZ Program Manager from Smart Airport Systems. We have Eugenio Donati, who is the co-founder of Aerovac Technologies. And then we have Diego Alonso, who is the Airport Ops Senior Engineer at Airbus. We would like to start our session by talking a little bit about what we've been doing over the last year. After numerous calls, deliberations with our industry partners, we have a working group. We are talking with the, how can we say it, the industry experts. We have finally decided that when we are talking about the autonomy of a GSE, we can split them into two different categories. So the first one is, we call it mobility of the GSE, and the second one is the operational task that the GSE performs. Now, this particular part that I'm going to talk about, we're going to focus a lot more on the mobility of the GSE. We have gone through a phased approach. So our first phase is going from point A to point B. So we want to make sure that autonomous GSE can safely go from point A to point B. Now, in order to facilitate point-to-point driving, there needs to be something in place. So if we talk about the first thing, is preconditions. What do we mean by that? So we are talking about the testing requirements, we are talking about introduction plan, and then we are talking about the trainings that the ground staff may have to take. All these elements together, they ensure that the autonomous GSE, when they enter into operation, they are safe. Then we are talking about general driving. Now, what is this? So here we are talking about visibility, signaling of the autonomous GSE. We are talking about what are the criteria to ensure that the GSE is driving according to the speed limits in different zones of the airport, smooth acceleration and deceleration. And last but not least, and very, very interesting, capabilities of the GSE. Based on the different things that the GSE can do, different capabilities, we have grouped them together, and we said, okay, fine, there are 4 groups of the capabilities: fundamental, basic, intermediate, and advanced. Now, if I were to speak about all of them, probably the whole day would not be enough. So what we are going to do, we are going to take one example, and we will see what the work is entailing, how the guidelines have been prepared, and how can an autonomous GSE perform a function. So we will take the example of basic capabilities. So right now, we have 4. So we are talking about identifying some of the no-go zones in the airport. Next one, we have either joining or leaving the traffic. Then we have driving within the congestion and parking. I'm going to take just one example out of these 4 basic capabilities that we have listed here, and we're going to focus on them. Because a system, I mean, for us, it's pretty clear, right? Like, what are these things, and we know how to do it. But a system needs to understand what it has to do in a sequential logic order in order to execute these functions very safely. So we will look at the example of joining the traffic. Here, what you see in the demonstration, we have 3 GSEs on the road on their airport. First thing that the GSE will have to do is identify if there are any stop signs. There you go. And the intersection where it will be joining the traffic. Once it has identified the intersection, it needs to determine the new direction of travel. Once the new direction of travel has been identified, it needs to observe the vehicles in the lane it wants to merge into, because there are many factors that it needs to consider. It has to think about the entry speed. What is the safe entry speed to join the traffic? It needs to be aware, okay, how much distance do I need in terms of clearance from the traffic in front and traffic in the back? And then it needs to consider, okay, how long before I join the traffic? Now, don't worry about the figures on the top, on the right-hand side. It's just an example. These are not the static numbers. It may depend on many different things. What is the operation? What is the load it's carrying? It's just for a demonstration purpose, right? Once GSE has calculated these items, it will have to, let's say, display the visual aid. So now you can see it's going on the right-hand side, so it's flashing the indicator just so that it's going to turn right. And last but not least, once it has joined the traffic, it will continue to monitor the vehicle in front, vehicle in back to ensure they're driving safely. This is just one very simple example of what are the guidelines that we've been working on. But some of you might be wondering, okay, well, fine, Sunny, thank you very much for telling me, what the GSE will need to think or what the system has to do. But how does it help me if I want to integrate the GSE into my environment? Well, don't worry. We have some use case scenarios. It's not an exhaustive list. Obviously, there are many use case scenarios, but what we are trying to do is provide you kind of like a template that you could utilize. So we will look at them very quickly. Scenario number 1. Now, it's a very simple operation. You just want to have an autonomous GSE to go from an outdoor staging area to another. You have nothing in between, just a straight, simple road. Well, it's fairly simple operations, no? Let's add a little bit of more complexity. You have an intersection, you have a tunnel. What do you do now? So in this case, the first example that we looked at was pretty simple. Maybe you are happy with the fundamental capabilities of the GSE. But now that we are introducing a little bit more complexity, the capabilities of the GSE needs to be a little bit more advanced. Now let's look at the third scenario. Well, we have a taxiway now. Increased complexity, right? Now we add an indoor staging environment. Why don't we make it more complex? We have an indoor staging area, and now we are going to ERA with all this complexity that we mentioned before. And last but not least, unfortunately, there may be some incidents on the road, so GSE might need to take some diversion. Anyway, like I was mentioning, these are just very high-level examples and the use case scenarios for people who would like to utilize the guidance. So what you can do, you can, based on these templates, you can prepare your own use case scenarios. You have the guidelines and the capability of the GSE, and you can put them together, and you do your own self-assessment to determine what kind of GSE do you require. So this is what we have been working on. Now, I would like to give the stage to Cyril Lebu. I want you guys to hear from him what they've been doing in terms of doing the implementation of autonomous GSE at the airports. Cyril, please.
Thank you. Thank you, Sunny, and thank you for having me. Hello, everyone. Go to the next one. So I will try to give here the GSE manufacturer approach to autonomous GSE, especially autonomous GSE manufacturer. So I work for a smart airport system. Most of you will know the main group, TLD group, that we are part of. So we have started, I think it was 4 years ago, with a prototype, and now we are starting to have a real operation with autonomous GSE, and in particular with the TractEasy. So the TractEasy is an electric tow tractor. Many of you will recognize the Jet 16 that is based from. There is actually a lot of modification inside, obviously a lot of technology and sensors, so I won't go too much in detail about the technical part today, because I think what we are interested to talk about is the implementation and the next step for larger scale adoption of autonomous GSE. So that's what we are going to talk about today. The TractEasy you can see here, it's a vehicle that is capable of autonomous operation today, specifically the point-to-point scenarios that Sunny mentioned. That's the use case we are focusing on today. So I will try to give you some example of use cases and discuss current situation and future situation, how we see it. Go to the next. So where are we coming from? So as I said, in 2018, we started this prototype with a partner that is specialized in autonomous software. We started more focusing on logistic sites. So like car manufacturers, so PSA, it's Peugeot in France. We still have some operation in a logistics side today as on airport. So we have two different, I would say, business units. And we are learning a lot from each other because obviously on logistics, you have the robotics for many years. So there is a lot of learnings we can get from a logistic site. And we are trying to bring this knowledge also on the airport side. So speaking of airports, we started in 2019 with Japan Airlines, the first deployment of an autonomous baggage tractor. So we have, and we still have today, 2 tractors into operation at Narita Airport. So we are doing the transfer between the main terminal and a satellite terminal that we are doing fully autonomously. With Changi Airport also, we have started a fleet deployment, so we have several track TZ as well, and we are doing also luggage transportation with baggage carts. In 2021, we started an important project for us with Avinor, so in Oslo. It's a project receiving fundings also from the European Commission, so we are starting to go to the next step already with harsh weather capabilities. So trying to bring the track TZ from basic scenarios to more complex scenarios, trying to work also on the 24/7 availability. So where are we today? Starting from in 2022, we have reached around 30,000 kilometers driven with the autonomous GSE. So we are gathering a lot of knowledge. We are trying to build on that, to go to the next step. So now we feel that we have a product that is working for point-to-point scenario, basic scenarios. Even in May, recently, just a few weeks ago, we started commercial operations on the outdoor scenarios. So we are going from a staging area to an aircraft, unloading cargo. I mean, taking the freight that has been unloaded, we pick up the freight and we move it to an outdoor staging area. This without any safety driver on board, without followers or anything like that, just a supervision, just a remote supervision. So we are progressively moving to more and more autonomy. So current situation today, as you know, there are fundamental differences between public roads and airports. So obviously technical ones, the speed on airport is not the same. The traffic rules, they are specific on airports. You have to cross taxiway sometimes, for example. You have the jet blast area. So now that we know that, how we move on to the next step. So we know also there are differences in terms of regulation, in terms of standardization. It's moving fast on public roads because there is obviously more money, there is more at stake, there are big companies like Tesla, etc. On airports, we are a smaller business, aviation business is smaller, but we want also to move to autonomous GSE. So how do we do it without regulation? The approach we have been taking also with IATA is to work on standardization, to have a set of guidelines that are created and that can help scaling up with more operations. So that will help defining scenarios, defining use cases that we can bring to airport, to airlines, to ground handlers, to have more operation on the ramp. So that's important work we are doing with IATA. As Sonny mentioned, today it's more focusing on the point-to-point driving, but there is still a lot of challenges moving forward with the maneuvering areas. So today, when you are arriving around the aircraft area, there is still some manual input that is necessary because there are just too many equipments and there is no rules for autonomous GSE. So it's remaining a complex challenge. So moving forward, our implementation vision in the short term is to focus on what we call the best use cases. So what's the best use cases? It's the scenarios that are, for example, long distance outdoor driving. That's going to be a good business case, but also a good technical case. So we are trying to find more projects. As you've seen, we have several ones. We don't want to expand too quickly. We want to find projects that can be valuable in the future, that are not just short-term POCs. Because today, this technology is still a little bit difficult to implement, and there is collaboration needed. So our approach is to find solid and long-term projects for long-term collaborations. So concretely, how does it work? We have always a proof of concept phase with safety drivers. So that means we have someone on board. We are gathering experience. We are gathering KPIs in terms of safety, reliability, and operations. Then we can move on to removing the drivers with a close supervision. So we can call that active supervision. And then we move to level 4 in full driverless. So with passive supervision, for example, someone that is monitoring a fleet of 10, 15, 20 vehicles. And that's the next step. So I have just a short video to end the presentation. It's super short, actually. So that was taken at Changi Airport. So we did some experimentation in driverless here, outdoor and indoor scenarios. So we are also looking at expanding with more use case at Changi, also for cargo transfer, in top of luggage transfer. And hopefully we'll have more press release in the next few weeks. Yeah, that's it. Thank you. And will I take a question at the end?
Yeah. Thank you very much, Cyril. Now I would like to give the floor to Eugenio to speak his experience of implementing the autonomous GSE at the airports.
Awesome.
Oh, you see, we are not autonomous, so this is why we have a problem. This is not the right presentation, no.
Yeah, I know.
If you don't mind, can we give the floor to Diego and then we do it after? Sorry. You see, this is why we need autonomy. Okay, Diego, do you mind if we give the floor to you, please? Sorry. Thank you. And then usually we go to you afterwards.
Okay, let's see if it works now. No, apparently not.
Wrong one.
Okay, I can make the presentation with no slides, no support, but it will be a little bit more boring.
Well, while we wait for the presentation to be fixed, do we have any questions for Cyril, for example, or for myself? From what we spoke, any about guidelines or anything about implementation approach? Okay. No, nothing? Okay. Oh yeah, please, go ahead, Harpreet. Can somebody bring a mic here? Yeah, okay. Well, to be honest, we started looking at some of the items such as we have been talking about, let's say, staff shortage. Then we were looking at some of the damages that were been caused. We did a risk analysis to understand what is better, where do we go, or what part do we need. This is the reason why we thought, okay, well, the technology is there. It's going to move forward regardless, even if we don't take the approach. But what is better for the industry? It's better that we have a set of guidelines that from the beginning, people can follow, industry can follow, so everything is standardized. Doesn't matter if you're operating in US, Australia, India, wherever. Everybody is going by the same rules, same guidances for the autonomous GSE, and it can be integrated safely and easily everywhere. So that was our approach in terms of going for this particular assessment and studies.
Okay, thank you, Sunny.
No problem. Any other questions that we have? Yes, please, to Bartu back there.
Hi, Cyril.
Hello.
Hi, everyone. You mentioned that this unit is already commercially deployed at a station. Can you give us some examples of targeted benefits?
Yeah.
And
okay. Yeah. Thank you, Bartu. So yeah, what we are doing commercially today is it's the main operation we have. It's on the cargo side. So the benefits we see concretely, it's to be able to reach larger scale operations. So for example, the operation we are doing in the US right now that are starting to be more commercial operations, we still have a big team around it. So you don't have like straight direct benefits from doing commercial operations, from picking up freight from point A to point B. With the several units that we have today, there is no concrete direct benefits, but it's laying the floor. It's being an early adopter of the technology to be able to scale it up and reach the benefits after. And as I talked during the presentation with the supervision, we want to have a ratio about 1 people for 10, 15 units today. So we want to automatize all the point-to-point driving and having just 1 people for supervising 15 vehicles. That will bring direct benefits in terms of economics.
Thank you, Cyril.
So I take over.
Yeah.
So, hello everybody. I'm Diego Alonso, and well, I may say that I think I'm one of the pioneers talking about automation in the GSE world. So I'm very happy that to hear, to listen to everybody's talking about automation. So that is coming back. We are going to talk in this presentation about, let's say, the GSE really getting to the aircraft. It's not from point A to B, but really getting close to the aircraft. So it's not something that is being done overnight. We've been working on this for several years. And you see, I mean, we started nearly 10 years ago. And at that time, let's say, labor shortage is not something that was really identified as a big issue, as it is today. That is clear for all the industry. We have more the problem of ground damage. That was really the key that was leading to us. So was not evident there, but we started from there. And we are going to go quickly on this. So what we did from that moment. So we need a kind of a vision where we would like to go. And this is something we made. We made a kind of video that I guess many of you have seen, is that we thought, engineer kind of a single MAM ramp operations, where we have an automated ramp and connected ramp, where we don't change radically the aircraft or the airport. We are not making any trenches, that everything that could be retrofitted, and we just make slight modifications to the vehicles, so that it can be retrofitted, and we can think of it can be deployed widely. So again, the concept is, can we make 320 turnaround just with one single person? So that was the challenge. So what do we need for that? So one of the key enablers was, can we make GSE dock automatically to the aircraft without anybody involved in the driving and staying, making all these things? So that was the challenge. That was the vision as well. And from there, we started to work together. So we had a lot of partners. So the slide is what it fits. So we have from sensor manufacturers, I mean, you see IFM6, so really at system level, to integrators, GSE manufacturers, you see a lot of them, airlines, airports don't fit there, and also standardization bodies like IATA, ICE, or others. So we get together, we work, we started to connect and see and try to get together. Where do we go? What can we do? What can we get together? And one of the topics we identified is that we need standards. We need the standards because mainly on the interfaces, so everybody would make their own system, their way of working, but the interfaces should be the same. We need to, let's say, focus on the solutions and have the interfaces that are standardized, so that we can save a lot of discussions later on. And I'm just putting some examples. So we have European standards on the left-hand side that we are revising, that to integrate let's say remote, autonomous, more automated operations. We have AHM that we are working on that, but let me talk to you about 2 examples that are, let's say, quite important in this development. So the first one is the aircraft markings for ground support equipment alignment. Is when we start discussing, they said, look, we need something on the aircraft. Theoretically, we thought maybe if you see the AICs, the aircraft, you see the doors, it should be enough. But because of cost, because you want to have 100% reliability, many manufacturers tell us we need something on the aircraft. Okay, so that's something we put together, and we said, okay, we need something that it needs to be seen from 20, 30 meters away, that gives you the door identification, the door position. So we put everything together, and we came up with reflective markings that we developed together with ADTech and all the industry. So if there is a need to put something on the aircraft, it's very retrofittable. It's just stickers you put below, and there it goes. So that's ready. Because the previous situation is that you see each airline, they have different markings. You have a kind of L shape, T shapes all around the doors, and it's not working. It's not working because you go to a different station and you have a different setup. So now you have a standard. So end of the discussion, if you want to have markings, is defined, you want for automation, it can be used, even for manual docking. And the other one that was issued 2 years ago, that the other one is just been issued a couple of weeks ago, is you have an equipment, so being a passenger boarding bridge, passenger stairs, you dock to the aircraft, okay, if it's automated, there's nobody there. Who is going to give the thumbs up? Well, that's a topic for discussion. Who is going to give the thumbs up to the cabin crew? So we, again, discuss, and to avoid endless discussion with every single station for the different manufacturers, just to standardize the interface. So we said it's a very simple kind of green, red, light setup where we have this. So it's available, and so we just need to use it. So, and at the same time, we said we have to test, and this is what we've done. So you've seen a lot of mock-ups worldwide, so that's from Spain, Canada, US, but it's been in France and in Germany. So there's plenty of mock-ups that every manufacturer that has been playing around, just to gain confidence for each equipment. You say, we build a mock-up, we play with that. So the next step was to, let's say, play test with the commission aircraft. So we have some 747s in Chateauroux and the commission 767s in the UK that we use to play with these vehicles. And the next step is to have the real aircraft. So we've got some, for example, cargo loaders with really in Charles de Gaulle. We'll talk later on. And even you see the markings just below the doors with EasyJet, that were flying for 5 aircraft with these markings, with passenger stairs that they were using for test. So there's been a lot of activity on testing and to gain confidence. So to the point where we can really say, okay, are we ready? So the definition for me already is that there is a customer, somebody has bought this, and we do have some equipment that we can say that we're ready. For example, there you go, the boarding bridges. We've got at least 3 manufacturers that have this capability to make first remote operations. So you will have somebody with a console that is able to drive many boarding bridges in different gates. So you have this remote and the automated operation. So that is not only driving, but just push a button and say it will dock to the aircraft. And as I said, there are several manufacturers, and it's worldwide. So you have in the US, you have in Spain, and even in Australia and New Zealand. Around the aircraft, the other vehicles is cargo loaders. So we've seen that we've got, for example, we're in Paris. So here in Paris, in Charles de Gaulle, Air France are retrofitting with markings, and they are making the automated docking this year for all their long-range fleet. So including 330, 350, and next year 777s and 787. And the rest of the vehicles, you will see, is a little bit more complicated. So you see here the map, that all the places where we've got automated docking. So you see in the one in Orlando is for JBT, that's got a customer in US, but it's not really in Florida, but somewhere else. And that's the pink dots, and the blue dots, that's for boarding bridges. So we've got from, let's say, US, Europe, Middle East, because it's Istanbul, but the airport on the Asian side, and Australasia. And the rest of the vehicles, well, we've talked a little bit about the stairs, the bell loader. There's been some small developments, but that's something that we need to work on. And catering, cleaning, PRMs, there has been some, let's say, the pre-steps wouldn't be too difficult to accomplish. So we already have today GSE that are automated, they can dock automatically to the aircraft. Okay. So the question is, what's next? So we need to continue the development of all the vehicles to the other GSE types. So that's we are focusing mainly on the vehicles that dock to the aircraft or aircraft doors. So let's say pushback is another discussion, but we need to finish with the passenger stairs. Have a viable. I mean, viable means not only technical but economically that is affordable for the. We cannot spend the same amount of the equipment cost to make this option for a belt loader. So catering cleanings, trucks, pyramid vehicles, and have development this map to have something at the scale that can be seen worldwide. So at the end, we want to have all the vehicles docked to the aircraft automatically, at least the possibility. Maybe we'll see if somebody uses it or not, but at least technically feasible and test it and it works, so that's the possibility already running. The next topic is standardization. We need the standards, if it works. Because we need the standards to communicate, because when you have automated vehicles, you need to communicate, give information, and the information flows, what is the content, the format, this is something that we need to work on. And well, the final topic is integration. I mean, how are we going to make these vehicles work together, especially in a non-fully autonomous environment? Because the easiest setup is when all vehicles are autonomous. In the moment you have a kind of mix ramp with autonomous vehicles, people around driving, is the most complicated scenario. And this is the one we are going to have for quite some years. And that's it.
Thank you. Thank you, Diego. Eugenio, let's try it again and see if it works. Yeah, there we go.
Awesome. Hi, everyone. It's great to be back on the stage at the International Ground Handling Conference. Apologies if I look a little bit tired. I just got off an 11-hour flight from Los Angeles. And as I got out of the plane in Charles de Gaulle Airport a few hours ago, I saw the longest passport control line I've ever seen in my life. And so I texted Sunny and said, what should I do? Maybe I should cut the line. I was able to convince the people to cut the line, then got a taxi, got here, and then the taxi driver says it's 58 euros. And I look at my wallet and find 55 euros. And so I convinced them to take 55 euros and $1. Yeah, it's great to be back here. Quick introduction, I'm Eugenio, the co-founder of AirVact. We are based in San Francisco. We make autonomous software for GSE. Super high level, this is, we build software, so we don't build any of the vehicles, any of the actual GSE. This is purely self-driving software, and combined with our hardware kit, makes vehicles fully autonomous, as a retrofit. A little bit about our team. We put together the world's leading airport autonomy engineering team. We're based in Silicon Valley, and so we just went around and hired some of the smartest people in self-driving from companies like Google X and some of the leading universities out there. Also very fortunate to be backed by some of the leading investors in both aerospace and autonomy, including the backers of some of the world's most iconic companies in the spaces, from SpaceX to Tesla, Boom, Supersonic, Cruise, and whatnot. And that's kind of our vision, our mission. We want to take ground handling, a pretty old-fashioned, outdated industry, and transform it, kind of bring it into the 21st century with autonomy built in Silicon Valley at true scale. A little bit of a recap of what we've been up to in 2021. We first introduced AirVact to the world at the GSE Expo in Las Vegas, where we gave rides to many of you on our first self-driving tractor. We also went to Prague, and I think to every single ground handling airport conference out there. I think in the last 6 months of 2021, between July and December, I took more than 50 flights. So yeah, I'm pretty sure we covered every single conference out there. We then realized that the key to deploying, first to building autonomous GSE that can be deployed at scale, is that we need a lot of data. Data is the big kind of make or break lever in autonomy, whether it's in this kind of industrial use cases or whether it's on the open road. Whoever has the most high quality data essentially tends to win, tends to build the best product. So we went out there, we built a proprietary mapping kit that lets us build a digital twin of a major airport in 2 hours. So we go in, we install the kit that you see here on one of our customers' vehicles, on any vehicle, can be a truck, can be a GSE, then we drive around the airport once, and in 2 hours we build a one-to-one digital twin. Then we can feed to our autonomous driving system, and it instantly learns how to drive there. And we build the world's largest data set of airport driving data, including 5 of the top 10 largest airports in the United States. And we are also very humble, my co-founder Raymond and I, to be recognized by Forbes as the 30 under 30 young entrepreneurs for the work that we're doing at AirVac, revolutionizing ground handling with autonomy. So quick look at what we're up to in 2022, and as some of you might remember from Prague a few months ago, Raymond and I started this company in a garage in Sunnyvale 2 years ago after graduating from college. And when we started this company, we really wanted to build kind of an enduring business that actually deploys autonomous GSE at scale. What we see in autonomy broadly is that there's a lot of research and testing and proof of concept and this and that, but we want to be laser focused on actually deploying what we built in real airports, in real operations. And so we are incredibly excited to announce that we have 3 launch customers. The first one is GAT, which is a national ground handler in the US. We announced our partnership with them a few months ago. We are very excited to work with them. They have a bold vision for the future of ground handling. The second one is someone that you probably, I'm pretty sure most people in the room have flown on. It's one of the top 3 global airlines. And the last one, also a name that you probably recognize as well, one of the top 4 global ground handlers. We're thrilled to be working with all of them. They have a bold vision, a very exciting vision and plan of what the future of ground handling in airport logistics looks like. This is our tractor, one of our tractors that we retrofitted right now at SFO in real live operations. And I took a few clips of the tractor driving right now in real operations at SFO. So this is the tractor. See here, we are handling a 3-way intersection. We build handling of all sorts of intersections, 2-way, 3-way, 4-way, stop signs, whatnot. We then see the tractor here crossing an active taxiway. We recognize and especially avoid and give right-of-way to aircraft. And then, of course, we make sure that a tractor only navigates, only drives in areas of the airport where it's allowed to. So here at SFO, there's this red and black security light kind of no-go area. And if you accidentally drive there, even a few inches, airport police comes. So we definitely don't want to drive there. And yeah, so this tractor is right now in live operations. And if tomorrow morning you want to hop on the 9 a.m. United flight back to San Francisco, you can come see it in person. And a little bit of what we're going to be up to for 2023. So 2022 is the year when we put in the first units, start seeing autonomous GSE in real operations at some of the world's biggest airports. But 2023 is the year in which autonomous GSE is truly going to scale. And there are 4 pillars that kind of underpin this rapid scale-up. The first is being OEM agnostic. We don't, again, our expertise is not building vehicles. It's just not what we know how to do. So we go in, customers have these large, diverse fleets. We retrofit them all at once, regardless of who made the actual underlying GSE. This is proven on real airside. So we've taken a tractor to major airports, and that's what we're going to keep doing for the rest of 2022, and implementing in real-world cargo and baggage operations. We've spent a lot of time kind of banging our head against the wall, building, kind of very cutting-edge navigation capabilities specific to the airside. Everything from taxiway crossings to recognizing all sorts of GSE. These are problems, essentially, that need to be solved if you want to deploy autonomous GSE at the airport. But you don't really find these use cases, these scenarios outside of airports. So it takes a lot of kind of domain specificity to be able to do this. And of course, training a model exclusively on airport driving data, and we have plenty of data that we spent last year flying around to get. I also wanted to take a couple of minutes to recognize the work that has been done with the GAD Automation Working Group. The reality is that without standards, without guidelines, without regulation, GSE autonomy is never going to happen. That's just what it is. And IATA has been leading the way globally with the autonomous GSE framework. Essentially, this is, as Sunny mentioned before, this is a set of guidelines and standards on what capabilities, what features autonomous GSE needs to have to be deployed at scale. And this is work that we started, I think, more than 2 years ago with Massimo and Steve and everyone with the working group, and it's going to be published in the next edition of the Airport Handling Manual. Quick recap of what we're going to be doing for 2022. So as mentioned, we have customer deployments in the spring, in the summer, and in the fall. We're then going to be at the GSE Expo in Paris, just a few kilometers from here, and also GHI in Dublin. So we hope to see and meet with many of you there as well. And then I'm going to be in Europe in September, October, so happy to meet in person. And if you're ever in San Francisco, you can always reach out for a ride on our self-driving tractor. And that's it. Thank you.
Thank you. Thank you. Thank you, everyone. So now, just before we open the floor for questions and answer again, I would like to mention just one thing, as what we talked about, the guidelines, about the standards. We are right now expecting to publish them in the IGHM 43rd version that we would like to publish by the end of the year. Our next step is to start working towards the movement of the GSE within the ERA area. So we are talking about positioning of the GSE, we are talking about the docking. So this, you can expect to have it by the end of next year. Now, I would like to open the floor for everyone to ask any questions that you have for any of the speaker, please. You can either do it by the application or you can raise your hand. We have a gentleman here, please, if we can get the mic to him. Here on this side. Can you raise your hand again, please, so he can, yeah.
Good afternoon, everybody. Right now, we were talking about autonomous GSE, which is a very unconventional method of handling ground handling. So, but when we are talking about this, we are the other part of the ground handling is still going in a conventional way, right? Just like we are thinking only of that equipment is being without driver, it is being operated. But why don't we go one step ahead and think like instead of the same way of operation, since we are talking about such a advanced method, for example, in an aero bridge, right now we have already started ground power and air conditioning. We are taking connection from the aero bridge. Because of that, we are doing away with ground power and air conditioning unit. Movement of ground power and air conditioning near the aircraft. Like that, like baggage, for example, departure baggage anyway traveling a long distance in the airport, maybe kilometers also, to reach the BMA, baggage makeup area. Like that, why don't we think of a system where this baggage can come right up to the aircraft, maybe through underground, where that service road is there, we can take it underground and reach somewhere near the aircraft. Because this also is a bit out of the way and a bit long way to go, like autonomous way of, and the risks are already there. Like when you're operating near the aircraft and docking on the aircraft, risks are there. Like if even the arrival baggage and even that problem of receiving the baggage late, all will be addressed with this.
That's a very good question. And what we are trying to do right now is we are looking at the technologies that are existing, and we are providing a platform by having guidelines and standards to make sure they work functionally. And as I was mentioning, we have few phases. Right now, what we talked about was a little bit about driving from point A and point B. So that is a normal thing that we worked on. Then, as I mentioned, now we are going to working on docking and stuff, which Diego already gave the example. There are some standards. So we are taking it phase by phase, and probably that will be our next phase, what you're talking about. But we need to start somewhere in order to get somewhere. So
one more example is this water cart and toilet servicing and all. If you can provide a point, like fuel refilling, we are already having hydrant points. Like that, a potable water point, so that we have to only connect the pipe.
But this is what we are going to do in phase 2. So as I was mentioning, movements within the ERA, including the positioning of the GSE. So identifying the docking points, GSE can go there itself and, park itself in order to dock properly. So this is plan of it, and if you would like to have more information, please feel free to, we can speak about it outside. We have the IHN timeline, and I can provide you all the information, but we do have it in the pipeline.
Right, thank
with
you.
us. Yeah? Thank you. Do we have any other questions? Yes, please, here on the, Thomas.
Excellent. Good afternoon. A question for Eugenio. I think what you're doing in terms of mapping the airport is really an excellent idea. I just see a challenge, and I'd be interested to understand how you've looked at this in terms of life cycle of that mapping. And then also, dealing with the operational situation where you've got road closures, you've got works, you've got markings which change and so on, and just keeping that up to date in order to make sure that your equipment, which is using that digital twin as a base, can have the most effective or most up to date, I guess, information. There's also lots of other applications for that data, which we can talk about in coffee break afterwards. I've got some ideas to share with you.
Of course, yeah. So the thing about airports is that they're remarkably, they don't change a lot. Most of the infrastructure at the airport, whether it's buildings, lanes, and features, taxiways, runways, they don't really change. So what we do with a map at first, or at least they don't change, very frequently. They do change in time scale of, months or years. So with the mapping, we have this, one pass of the infrastructure, so we have one-to-one twin of that. And then most of the features that do change, for example, if you might have construction, you might have some road closures, these don't need to be updated in the map. So this is something that the vehicle, recognizes with its software on-prem. So when the vehicle's driving, sees like, oh, there's some construction here, oh, there's a vehicle in the middle of the street, I can just go around, I can just take another route. You don't need to remap. Mapping is mostly about essentially making a copy, building a twin of the large, physical, fixed infrastructure, like buildings, tunnels, taxiways, which don't really change. And if they do change, you just drive again once over, and you update the map in, as little as 5 to 10 minutes.
Thanks.
Thank you. We have a question here in the front, please.
Hi, just going by what the previous person just asked, I have a real example of our aircraft that got damaged during a turn next to a building in a certain airport. I don't want to disclose the name. And this was only due to the building not being reflected correctly on the Jepson chart, okay? So I was just wondering, in all this technology, I'm sure you would also have a kind of a proximity warning system that would, as you're approaching, even if there's an error in the mapping, you're already mitigating it, that there would be a warning and there would be something that would stop the vehicle. I would presume that, actually, and I hope it is there. Thank you. That was a question.
Yeah, I would also presume that. Yeah, of course. So just to be clear, mapping is not, we don't just rely on mapping. We have a few layers on the vehicle of perception, collision avoidance. We have all sorts of sensors that essentially act as a, fully 360 aware driver that spins its head 10 times a second. So the map is not the primary way of driving, if you will. So of course, as the vehicle is driving, it's recognizing all sorts of vehicle, aircraft, people, whatnot, lanes in real time using on-prem software, and it's not just purely relying on the map. I would agree that only relying on a map would be a little bit foolish without any collision avoidance system or anything on the vehicle, of course.
So, sorry, we are running out of time now, so I would just like to conclude the session by saying 3 things. We heard today that from GSE and system manufacturer and from the aircraft manufacturer, what are the status of the autonomy in the industry. Feel free, please, to reach out to each one of them individually if you would like to talk to them, or reach out to us and we can put you in touch with them. With that, if I could request you to give them a round of applause, and we would like to conclude the session. Thank you, everyone. Thank you, guys.